Welcome to Casense.
Think about the calculator app on your phone. Once the code is written, the job is essentially done. 2 plus 2 will always be 4, and the software never has to relearn math. But building an artificial intelligence is different. An AI model is a living system that can lose its edge. As the world around it changes, like a snowy winter melting away into summer, the model's performance begins to slip. This happens because of drift. An AI only knows what it has seen in the past. It has a fixed memory, but the real world is always moving forward, leaving that memory behind. Imagine an AI trained only on shopping habits from December. It will be an expert at suggesting coats and boots. But come July, that same AI will still be recommending heavy parkas to people heading to the beach. To fix this, we use MLOps, or machine learning operations. You can think of it like a professional maintenance crew for an AI. It is the engine that keeps the model's memory perfectly synchronized with the real world. This process aims to move AI beyond the stage of a one-off experiment, creating a system that is designed to stay accurate over the long term. Let's look at an online shopping app called Cart IQ. They built a recommendation AI to help customers find perfect products, and at first it worked brilliantly. Step 1. Preparing data. Organizing customer habits into clean data is essential. In Step 2, they trained different AI versions, testing them to find the top performer. Step 3. Deployment. They pushed this best model live to make real-time suggestions. The launch was a massive success. Because it was winter, the AI perfectly suggested boots and scarves, and customers were happy. The Cart IQ team felt like they had crossed the finish line. They assumed the project was over because the code was live. But months later, sales began to plummet. The AI was making terrible suggestions, even though the code hadn't changed at all. The problem was drift. The seasons had changed. Shoppers wanted summer gear. The AI's winter training was stale. This is where Step 4 comes in: monitoring and retraining. Cart IQ realized they needed to watch the AI's performance every single day to catch these slips. By feeding the AI fresh summer data, the team retrained the model. Redeploying it instantly returns accuracy. Cart IQ turned this into an automated loop. The system monitors itself, detects when the world changes, and retrains automatically, staying constantly up to date. This loop is what keeps the AI working. It's the realization that a model is never done, an ongoing cycle of watching, learning, and updating. This approach is vital when you are running many models at scale. However, if you are just doing a quick one-off analysis for a single presentation, a full MLOps cycle is likely overkill. The biggest mistake a team can make is treating a live AI as finished. Without constant monitoring, the system will eventually fail, and it will happen silently. You also have to watch the foundation. If the pipelines bringing in your data are messy or broken, the entire cycle falls apart before it even begins. Many teams try to solve this by simply buying expensive software. But tools alone aren't enough. You have to change how the team actually works together to maintain the system. At its heart, MLOps is about preventing that silent rot through good habits and consistent teamwork. We have to accept that the world will never stop changing. Because of that, the data our models learned on will always have an expiration date. By embracing the loop, you ensure your AI stays sharp. This constant cycle of learning is what allows these systems to keep working reliably in the real world.